Hello and welcome dear learners once again to Mathlete Minds. In this video, we'll be focusing on areas related to segments of a circle. So here we have a circle where the diameter has been drawn. AB is the diameter and this diameter divides the circle into two equal segments. Diameter is the longest chord in any circle. But it is not necessary that always we take the help of a diameter to divide the circle into segments. We can draw chords of other dimensions, other measurements in different directions and divide the circle into two unequal parts. AB is the chord over here and APB is the minor segment, ACB is the major segment. Similarly, CD is another chord in the oblique direction. It is dividing the circle into CAD one segment and CBD another segment. When the segments are removed from the circle, they acquire the shape. RM is the chord and RM is the arc length. PR is the chord and PQR is the arc length. So let's try to understand how we calculate the area of a segment of a circle. Now here we have a here we have a chord AB which is dividing the circle into ACB and ADB. Now, to calculate the area of this region over here, that is this ACB, the minor segment of the circle, what we need to understand is this whole area, from this whole area, which is basically a sector. If you look at the figure carefully, AOBC becomes a sector. And from the sector, if we remove the triangle, that is AOB, we will get the area of the segment. So the first thing that we do before we start calculating is we join the endpoints of these two chords to the center of the circle. So we generate a triangle over here. Now, next thing that we need to do is area of the segment ACB will be equal to area of the sector, minus the area of the triangle that has been generated with the help of the endpoints of the chord. Now, one thing must be remembered here. These are the two radii. OA and OB are the two radii. So automatically all these triangles, they are isosceles triangles over here. Now, in the case of supposing the angle subtended at the center is 90 degree. In that case, we will get over here a right angle triangle. So area of ACB will be area of the sector, which is pi r square theta by 360. We have discussed this area of the sector in the previous video, minus area of the triangle, that is half base into height. So when it is a 90-degree angle, the work becomes immensely easy. We take the help of these two base and the height, they can be interchanged. They are the radii, and base and height are all equal to the radius. So here, this is the formula that is applied over here. If we have an angle 60 degree at the center, then automatically this triangle AOB becomes an equilateral triangle. So in this case, we get the formula pi r square theta by 360 minus root 3 by 4 into a square. This is the formula for area of an equilateral triangle. So for an equilateral triangle, how do we get this as an equilateral triangle? If this is 60 degree, these two angles automatically will be equal because these are the radii, as I said earlier. So each angle becomes 60 degree and it is an equilateral triangle. Next thing, but it's not necessary that always you will get a 90-degree angle or a 60-degree angle away. You can get other angles also. So in that case, we take the help of a general formula, and these questions can also be solved with the help of that general formula for area of the triangle. Now let's, before we do that general formula, let us take up a question numerical based on when the angle subtended at the center is 90 degree. So here what we do is area of the segment corresponding minor segment, that is PRQ, that will be equal to area of the sector pi r square theta by 360, that is 1 by 4, because 90 by 360 is 1 by 4, minus area of the triangle, that is half base into height. So this becomes equal to 22 by 7. R over here is 20 square into 1 by 4 minus half into 20 into 20. So we can take out 20 square by 2 common, and we are left with 22 by 7 into 2 minus 1. So this becomes 20 square by 2 outside the bracket, and within the bracket we have 22 minus 14 by 14. So this is equal to 400 by 2 into 8 by 14. So 2 fours 8, 2 twos 2 7. So we are left over here with 800 by 7. So this is equal to 717, 717, 3 7 fours 28, 2 7 twos 14, 7 8 56, and you can continue. Only two places is required. So square centimeter. This is the area of this segment over here. Moving on to another question where the angle at the center is 60 degree. In that case, area of the corresponding segment ACB, area of ACB will be equal to area of the sector, that is pi r square theta by 360, that is equal to 60 over here, 60 by 160 by 360 minus area of the triangle, that is root 3 by 4 into a square. Here A and R will measure the same. So here we get 22 by 7. R over here is given as 14 centimeters, so 14 square into 1 by 6 minus root 3 by 4 into 14 square. So this becomes, we can take out 14 square by 2 common, and we are left with 22 by 7 into 3 minus root 3 by 2. So this becomes equal to 14 square by 2, 44 minus 21 root 3 by 14 into 3. So outside the bracket we have here 14 square, that is 14 into 14 by 2 into 14 into 3, and within the bracket we have 44 minus 21 root 3. So 114 gets cancelled and we are left with 7 by 3 outside the bracket, and within the bracket 44 minus 21 root 3. So let us simplify this further. We'll get over here 44, this is 7 by 3 and 44 minus 21 root 3. So here this becomes 7 by 3 into 44 minus 21 into 1.73. Value of root 3, two places of decimals. So this becomes 7 by 3, 44 minus, this is 63, carry over 6. This becomes 147 plus 6 is 153, carry over 5. And this becomes 36, 36.33. So 7 by 3 into 10 minus 3 is 7, 9 minus 3 is 6, and 13 minus 6 over here, that will give you 7. So now this becomes 7 by 3 into 7.67. So 7 by 3 into 7.67. So this can be again sorted out further. 7 7 is 49, 4 7 6 42 plus 4 46, carry over 4 49. So this becomes 53.69 by 3. So this becomes 3 1s 3 4 5, 3 7s 21, 2 26, 3 8s 24, 2 29, 3 9s 27, and again 2. So you can continue this. So this becomes approximately till 3 places of decimals. So next one, now we move on to understanding when the angle at the center is not 60 or 90. What is the general formula? As I mentioned, there is a general formula. Supposing the angle at the center is theta, any particular angle. Now, how do we calculate the area of the triangle? Area of the sector, the same formula, but for area of the triangle, if we go back to half base into height. Now, in this triangle, the triangle AOB, the base over here is, base is equal to, base is AB, and the height is equal to OL. So half base into height, that means half into AB into OL. We need to calculate this, half into AB into OL. So now let's see what is AB and OL. Now when we draw a perpendicular OL in this triangle, it divides the triangle, big triangle, into two congruent triangles. And so each of these angles over here becomes theta by 2 and theta by 2. The entire angle is theta. So by CPCT we can say that each angle is theta by 2 and theta by 2. Now if I take the triangle AOL or BOL, any of these triangles, AOL, supposing we take AOL, then in this triangle AL will be equal to R sine theta by 2. and OL will be equal to R cos theta by 2. So 2AL is equal to AB. AB is equal to 2AL, that is equal to 2R sine theta by 2. So the area of the triangle, that is half into AB into OL, will acquire this value half into 2R sine theta by 2 into cos R cos theta by 2. So this 2 and 2 get cancelled. We are left with R squared sine theta by 2 into cos theta by 2. So this is the formula for area of the triangle when the angle at the center is some other angle apart from 60 and 90 degree. But here we have used a trigonometrical function, so you must know the value of the angle theta over here. Let's take a question pertaining to it. Here the central angle is 120 degree and we need to find the area of the segment ACB. So area of the segment ACB will be equal to area of the sector AOBC minus area of this triangle over here. So getting back to the formula, area of ACB will be equal to pi r square theta by 360. 120 by 360 is 1 by 3 minus r square sine theta by 2 cos theta by 2. So here, because the theta value is 120, theta by 2 will become 60. So putting the values we get here 22 by 7 into r square. R square is 21 square away. 21 square into 1 by 3 minus this becomes 21 square into cos 60 into sine 60. Now this becomes 22 by 7 into 21 square into 1 by 3 minus 21 square cos 60 is equal to half and sine 60 is equal to root 3 by 2. So we can easily take out 21 square common from the brackets and we are left with 22 by 7 into 3 minus this becomes equal to root 3 by 4. Now, for the simplification, we get over here 21 square is outside the bracket. Within the bracket, we get 88 minus 21 root 3 divided by 21 into 4. So this is what we get inside the bracket, and 121 can be eliminated with this. So outside the bracket, 21 by 4, and within the bracket, 88 minus 21 root 3. So we'll simplify this further. 88 minus 21 root 3, and outside the bracket we have 21 by 4. So 88 minus 21 root 3. So this becomes equal to 21 by 4 into 88 minus 21 into 1.73. So this becomes 21 by 4. 88 minus this becomes 36.33. So this is equal to 21 by 4. This is 10 minus 3 is 7, 6. And again we have here 7 minus 6, that is 1. And this is 7 minus 6, that is 1 over here. Then 8 minus 3, that is 5. So 51.67, 51.67 into 21 by 4. So 21 7 is 147, carry over 14, 21 6 is 126. 126 plus 14, that makes it 140. So 14 remains, 21 ones 21 plus 14, that is equal to 35. 3 remains, 21 5 is 105, so this is 108. So this is the decimal point away, divide by 4. So we get over here 4 2s 8, 4 7s 28, 4 1s 4, and carry over 110, 4 2s 8, and again 2 remains, 27, 4 6 24. So 24 and 3 again remains, so we can view our answer over here, square centimeter. So this is the area of this segment over here. Now on this question, we have a garden over here where it's a square shaped garden, and this is the ABCD, this is the lawn area over here, and these two are flower beds over here. So when we need to find over here the total area of the lawn as well as the flower bed. Only the measurement of the side of the square is given, that is 56 meter. Now, in order to calculate the area of the total garden, we must understand that these regions over here, these are segments over here, not semicircular end. These are segments that have been formed with the help of this radii, that is OA. It's mentioned over here. The center of each of the flower bed is the point of intersection of the diagonals of the square lawn. So if we draw the circle, semicircle from here with this radius, this region that we get, APD, the flower bed, is a segment over here. Similarly, BCQ is another flower bed over here, which is also a segment. So here we get two flower beds which have the same area, and the angle over here is 90 degrees. So let's find the area of the one flower bed, multiply it by 2, and to that we'll add the area of the square. So area of the flower bed over here will be equal to area of, say, APD will be equal to area of the sector OAPD, that is equal to pi r square into 1 by 4, angle over here will be 90 degree, minus r square cos theta by 2 into sin theta by 2. So this becomes equal to 22 by 7. Now what is r over here? We need to find that out also. OA is the radius of the circle. We are only given the measurement of the side of the square. So in that case, this OA, the diagonal AC becomes equal to 56 root 2. Diagonal of a square is defined by a root 2. Here a is 56, so 56 root 2. This is with Pythagoras theorem, very simple. So here 56 root 2 is the diameter. So radius will be OA. OA, which is the radius, will be 28 root 2. So we get the radius as 28 root 2. So this becomes 28 root 2 whole square into 1 by 4 minus 28 root 2 whole square. Sin theta by 2 is sin 45, cos theta by 2 is cos 45, so that is 1 by root 2 each. So that becomes 1 by 2. So this is what we need to simplify. Now 28 root 2 whole square can be taken out as common, divided by 2 can also be taken out as common. So this becomes equal to 22 by 7 into 2 minus, this becomes, we have taken out this whole thing common, so this is, we are left with 1 over here. So this is equal to 28 square into 2 by 2. This 2 and 2 get cancelled. And within the bracket, 22 minus 14 by 14. So on further simplification, we'll get over here 28 square, that is, we'll keep it as 28 for the time being, and this will become 8 by 14. So 2 4s 8, 2 7s, 7 4s 28. So this becomes 28 into 16. This is for one flower bed. 28 into 16 is the area of one flower bed. So multiply it by 2 to get the area of the other second flower bed also. So the area of the two flower beds will be given by 28 into 32. And to this we add the area of the square lawn, that is equal to 56 square. So this becomes equal to 28 into 32. 28 into 2 is 56. That is equal to carry over 5. And 28 into 3. 28 into 3, that is 20. This becomes 8 is 24. 2, 3, 2, 6, 84. So this was 28 into 2, 56. Carry over 5. And plus 84 plus 5 is 89. Plus 56 square is 3136. So if we add these two, we get 12 and 9, 10, 11, 12, 13. Carry over 1, 8, 9, 10, and 4032 square centimeter is the total area of the entire garden. Now, supposing a question like this is given, a chord 10 centimeters long is drawn in a circle with radius 5 to centimeter. Find the area of both the segments over here. So you need both the segments over here. Important thing is the radius is 5 root 2 and the chord is 10 centimeter. So if we analyze this, 5 root 2 whole square plus 5 root 2 whole square, this will become equal to, this is 25 into 250 plus 50, this is equal to 100. And if we take the chord PQ, the square of PQ is also 100. PQ square is also 100. So now this becomes an angle which is 90 degree over here. So to get the area of the segment over here, we get back to the formula pi r square into 1 by 4 minus, here we have our this thing, we can take the formula r square cos theta by 2 sin theta by 2, or we can take half base into height. Now half base into height, base is also 5 root 2, height is also 5 root 2. So, and r is also 5 root 2. So this becomes equal to 5 root 2 whole square, take it out as common, by 2, 22 by 7, minus, and there is 1 2 left over here, minus, here we have taken out everything common, so we are left here with 25 into 2, 25 into 2 by 2 outside the bracket, within the bracket we get here 8 by 14. This 2 and 2 get cancelled, 2 4s 8, 2 7s 14, so 25 into 4 is 100 by 7. So 100 by 7, that gives us 7 1 7, carry over 330, 7 4 28, carry over 220, 7 2 is 14, and again 6 7 8 56. So 14.28 square centimeter is the area of this minor segment over here. Now to get the area of the major segment, we can take out the area of the circle, that is pi r square, minus this area, that is 14.28 centimeter. That's what we need to do. Hope you like the explanation. Kindly like, share and subscribe to the channel and keep watching. Thank you for watching.